The reduced density matrix for the system is trace out environment, plain language meaning of the reduced density matrix. We are now looking only at the system, ignoring the environment. To do that, we mathematically trace out the environment, which means we remove its degrees of freedom and keep only what the system is doing. The result is a 2x2 matrix that describes the state of the system at time t. Here's what each entry means in words. Top left entry. This is the probability weight for the system being in pointer state S0. Its value is the absolute value squared of C0. Bottom right entry. This is the probability weight for the system being in pointer state S1. Its value is the absolute value squared of C1. These two diagonal terms describe the classical looking part of the state, how likely each pointer state is. Top right entry, off diagonal. This term links pointer state S0 to pointer state S1. It is equal to C0 times the complex conjugate of C1, multiplied by the overlap between environment state E1 at time t and environment state E0 at time t. Bottom left entry, off diagonal. This is the complex conjugate of the top right term. It carries the same information, just reflected, to keep the matrix Hermitian. These off-diagonal terms represent quantum coherence. They are what allow interference between S0 and S1. Key physical insight. The overlap between the two environment states, the quantity written as the inner product of E1t with E0t, controls whether the system behaves quantum or classical. If the environment states remain similar, the overlap is large. Coherence persists. The system behaves quantum mechanically. If the environment states become orthogonal, that is, distinguishable, the overlap becomes zero. The off-diagonal terms vanish. Interference disappears. The system behaves classical in the pointer basis. This is decoherence in one sentence. Decoherence is the suppression of the off-diagonal terms because the environment learns which pointer state the system is in. Key factor. The off-diagonal coherence is multiplied by the environment overlap. We define a quantity called O of t, written as O parenthesis t. This quantity is the overlap between the two environment states. The inner product of environment state E1 at time t with environment state E0 at time t. In everyday words, OT tells us how similar the two environment states are. The expression OT. This is the environmental overlap function. It is a complex number whose magnitude quantifies how similar or distinguishable the two environment states are. The expression bra E1 of t ket E0 of t is the inner product between the two states of the environment, E1 of t and E0 of t, which have become correlated with the system states S1 and S0 respectively. This inner product measures how similar or different the environment states are. If OT, zero rapidly, because the environment records which branch happened, the off-diagonals vanish, branches decohere.